Hello, this is the Tepid Coder here. In this video, I want to go over the basics of creating classes in C++, how to copy them, how to move them, how to make it so that when you copy with an assignment operator overload, it acts how you expect it to. So let's get a basic little class running here. I'm still going to code these projects somewhat in C as well. And the reason for that is I don't like using things like cout. And I can explain why at some point, but the short reason being, if you do cout, you have something like, I don't know, float f 17 or 7.77. You could do f like this. Right? And the number of decimal places it shows is controllable, but I cannot for the life of me remember how to do that. And it's really easy to do if I were to do this in C. I would just say, I'm printing out the float, and I can see how many decimal points I want, like 0.7. I want 7 places, I want 2 places. I can pad it with zeros in front. Like, this is all really easy. This up here requires a bunch of functions you have to remember, and it sets like some kind of state in your standard output or your file handle. And you have to remember what that state is and correct it sometimes. Here, it's not based on state, it's based on what I want right now on this one statement. It's way better. And things have gotten a bit better with like standard format, or like V format or V format 2. Or like if I just use this and I say like, I don't know, let's see, format orgs, right, something like this, blah. I don't know, let's pretend I still have f, right? Float f equals 7.7 f. I could still do that, right? But again, I still have the issue of like, how many decimal places is that going to be? I haven't looked into this V format thing too much yet, so it's possible that I can do the same kind of syntax without worrying about state as before, but I'd have to look into it. So things might not be as bad in C++ as I'm thinking. I do sometimes use this, but anyway, I typically just do it the C way. It's really explicit what's happening. It's easier to debug, I think, too. The advantage to the C++ way, though, is you're never going to pass something that has a different size than what the format token specifies. And you're never going to, what do I say, format with the wrong type. So, for example, if it's expecting it to be something like a double, and you pass it char, and the char gets cast to an int or something, like it's promoted to an int, right? Then it's still only 4 bytes instead of 8, right? That's a problem. So you won't have that issue, and you won't be trying to format something as a type it isn't. Anyway, let's make a class. I'm going to make it be called like string. Now with a class, by default, everything is private, which means no one can see it. You can also put a private keyword and make it explicit for certain sections. And if you want something to be public where people can use it, you just say public : So everything below this is public, and everything below this is private. And you can make another, private down here, make another public, you do whatever you want. Anyway, typically what people do is they make their variables inside the class be private. So you have to access them through some kind of like function, like get some member, right? And over here you'd have like, I don't know, int some member, right? This would actually return an int then, and it would return whatever this value is. So think of a class as just being a structure. Yeah, structure string, and maybe the string structure has something like pointer to some string, right? Maybe by default it's 0 or a null pointer, or it's null like this. Like this is the way of saying that it's null in C, this is the way of saying it's null in C++, and 0 is basically treated as null anyway. Maybe you would also have something like size t, length, right? Number of characters in the string excluding the null terminator. You might have that. It's a pretty good string structure, right? If you need to make it bigger, you can maybe just use realloc and resize the block as needed. Anyway, the only difference between a class and a struct in C++ is that a structure has everything public by default. And in fact, you can actually use public and private inside of a struct, just like with a class. So That's something to keep in mind. I don't know why I put parentheses there. Anyway, trying to think what I want to have this class do. Let's do kind of what I was showing above. I'll go to size t, inf member, size t, let's say length. So it's length of the string. By default, it's 0. So both in structures in C++ and in classes, you can actually default the value. So whenever you create a new object of that type, if I say string s, it's automatically going to set this member to 0, just because I created it. So let's say I also have char, I don't know, pointer to m lpsc string equals null pointer. Alright, so by default it's going to set this to a null pointer, it's invalid. So what I'm going to do here, I'm going to say const char get string const void. Okay. I'm also going to do something like void set string const char string. Okay. Now, the reason I stuck a const over here is if something is constant, like a method in a class, it means that you're promising that this method will not change any of the members of this class. So you can think of this as being the state of the class. If any of these change, then the class itself, that instance of the class, has changed somehow. But if the method is const, it's guaranteed that the class will not change in any way. It's going to be the same between calls. So that's why I'm specifying it's const here. There's other things you can put here, like no except. You might remember like the try catch block with like standard exception e like this, and you can print like, you know, e dot what. That gives you the error message. I did that earlier in the video about parsing. You put no except, you're basically saying this will not throw an exception that can be caught with try and catch. So it's good practice to remember to mark things like that. Another thing you can do with modern C++, like 17 plus I think it is you can say no discard. So if someone calls this function, they're not allowed to ignore the return value. So if they say, like, say I have string s, and I say s dot get string. So you notice the syntax here with the dot is just like with structures. And if you have a string pointer, it's the same thing too. It's going to be an arrow, right? Anyway, if I do this, I try to get the string, and I don't actually assign something over here, right? Nothing equals this, it's going to complain. So I have to at least say const char, you know, p equals that or whatever. Now I'm actually using the value, and it won't complain. That's what no discard does. There's another one too, like you could say maybe unused, right? So if you have a function you've made but it's not used anywhere yet, you can actually write that there so that other people who are working with the code know that there's less stuff to actually be concerned about, right? We're probably not even using this function, so don't really look over it. You can gloss over it and not worry about it. Of course, like comments in code, it may end up becoming out of sync with the actual code itself. Anyway, so what do we have so far? We have a string variable, and we have the size of the string. Okay. We have an ability to get the string and the ability to set the string. What we need to do, though, for classes is we need to make it so that when you create a new instance of class, by saying, you know, string s, like right here, you need to tell it how to initialize everything. I mean, obviously we're doing that here, but you need to set what's called a constructor. This runs whenever you create the object. So it's going to be named after the class. I called this class string. You can see right here. And the default constructor takes no arguments. Constructors never return anything. And then there's also what's called a destructor. So when this variable is killed, goes out of scope, for example, it's tilde in the class name. That's what gets called when the object is deleted. So let's get a main entry point here. Okay, so what's going to happen here so far is I'm saying that I'm going to create a new object of type string, which is a class. It can be called s. Now when I make this, the constructor is going to be called. When it goes out of scope, here's the scope starting here, and it ends right here. So when it hits here, it's going to be deleted automatically, and it's going to call the destructor. The destructor is meant to free resources that are held in the class. In this case, it'll be a pointer to some block of memory, and it'll be, you know, the length of that block of memory, right? The size in characters. Now, I actually have to implement these functions. Right now, I've just defined them, but I haven't actually said what the functions do, like how they work. So it's going to be a bit different from classes, or not classes, but functions we've seen in the past, where it's just like, okay, you know, return type, function name, type targ, right? Type 2, you know, t2 arg2 dot dot dot, and then you give it a body, right? And then return whatever the return type is. That's how you've been seeing it. The only difference really is classes. After the return type, you have to put the class that the function comes from. So in this case, it'd be string : : So for all of these right here, between the return type and the name of the method, which is what the functions and classes are called, these are all methods, I have to put the name of the class : : So that's what we'll do. We'll say string : : string. That's my constructor, right? Maybe I'll label these for you. Constructor. In fact, I'm going to say default constructor. This is destructor. Okay. Now, if you notice, this takes no arguments. The default constructor is what gets called when you don't actually do something like this. It equals, not even equals, let's just say this. Like if I pass it like 1, 2, 3, this would expect a constructor which takes like 3 integers, for example. But because I don't actually pass anything to it, it's going to use the default constructor, which is this one. So just so you can see what's being called and when it's being called, how it works, I'm going to say string called. In fact, I can make this even easier. I'm going to say function, which basically this function right here just passes as a string the name of the function, which would be string. And it might even like put the parameters in there as well. So all I have to do here is just say %s called, right? Put it in quotes. Okay, I'm going to do string tilde string. So this is a destructor. I'm defining it now. Okay, so now it's going to say the destructor is called. I can get rid of this code here down. I don't really need that anymore. So at this point, I have made the constructor, the destructor. I need to make these. I'm just going to copy these, less typing. Okay, string. All right, and at this point, I'm going to actually wait. Let's give it a body. Let's actually return it. Or return the actual string. And over here, what we're going to do is we're going to say, I'm trying to think, if, let's see, string. I'll explain this in a second. But if it already is set to something, then what I'm going to do is I'm going to say free it. And let me see, string. Okay. So if this is not a null pointer, right? Just check and see if it's 0. And remember, null pointer value to 0, null and C value to 0, and 0 value to 0, because it's 0. Anyway, so if it's not 0, then we're going to free it, and we're going to set it to null pointer, which is basically 0. And then after that, we're going to make it so this internal string, obviously string equals obviously string, but we need to actually copy it, so stir do. Alright, so it's going to be equal to a copy of the string. In this case, we're asking for the string, so it's just going to return the string. So the reason I called this M stands for member, and anything that belongs to this class, it's like defined as part of the class object, goes here. And we're defining it as member. But if I defined a variable in a function, I wouldn't call it that. So inside this function, let's say I needed to make an integer, called it I something equals 0. I wouldn't call it mi here, because it's just a local function variable, you know. A lot of times when I make a global variable, I'll do something like, you know, int gi for global integer something else, right? You can initialize it, or it's going to be 0 by default. Maybe it needs to be 17, whatever. So that's just something to keep in mind. Technically, this right here could be written like this. And this refers to this class object right here. So whenever I call something like s dot, you know, set string, let's say testing, right? What's going to happen is, even though I'm not actually saying it myself, s is getting passed like this. It's passing a reference to s as the first parameter. And even though you don't see it in this function, that's happening. And the parameter is basically like this. It'd be string and this. That's what's happening. So this, in fact, it's not even an ampersand, it's this really, which is kind of funny. So its type is a type pointer, and it's this class is the type. We're in a string class, so it's string pointer. You really have string pointer. Ah, jeez, this. Anyway, so you could do that, but you don't need to. For any variables you define in this class or any functions, you can just call it like it's in like the local scope of the function. So in the scope of the method right here, any of the members you use or any of the other functions you use or methods you use can just be called as though it were in the same scope as in here, as though I had actually defined char m, sorry, try asterisk m LPSC string. If I had done that right here, it works just the same. So that's kind of interesting. So people generally don't like typing this arrow in front of everything, so what they'll do is they'll just put m in front of it. And that's what I'm doing here. I'm just kind of trying to keep things standard. Okay, what else? Right, so at this point, we have a string we're storing. It's going to be a reference to a block of memory that we dynamically allocated and need to free. So this is where the destructor comes in. The destructor is called. We actually need to free that. So I'm going to say if there is a string, it's valid, it's not 0, then we're going to free m LPSC string. In this case, I mean, we could do m LPSC string equals null pointer, but there's no point because at this point we're at the destructor. It's run out of scope or we've deleted it. Like, there's no reason we should ever need to do this at this point, so I'm not going to. So let me do one more thing here. I'm going to say here's the string, right? And I'm going to say s.get string. Okay. So we've got some errors. Let's fix those. Okay, so expected a comma or a triple dot before this. Oh, right, I did that as an example. That happens implicitly with classes. Okay, string isn't defined. That's because I didn't include string.h. String.h. Okay, so you can see the constructor was called string, and here's the string. That's what I did inside the main function, and then string destructor is called, and it frees the variable. Now, something I need to show you. Because this class has a pointer in it, anytime there's a pointer variable in a class, you run into some issues. We haven't run into it yet, but we will run into it. When you copy a class object, like you can imagine, let's see, I have int a and I have int b. So a equals 10, b equals a. When you copy something like this, it's fine, because it just copies this value into an integer. But if I have something like int a equals malloc 10, now it's a pointer to 10 bytes. If I say b equals a, what I'm really saying is, actually I can't do that, to be, there you go. It's an int pointer, right? This points to an int somewhere in memory. It's the first of 10 ints somewhere in memory. And this is a pointer to an int, which is going to point to a, which points to the first int of that block of 10. So this is a block somewhere in memory that has, 10 random numbers in it, because I haven't initialized them yet. If I do calloc and I say each one is like size of int, that's fine. And by the way, this is actually wrong right here, 10. It should have been 10 times size of int. That's actually 10 ints in memory. Otherwise, it's just 10 bytes. So that was it. Anyway, yeah. Here we have a block of memory. We don't know what's in it because we haven't messed with it. If I do this, I say size of int, 10. It's going to do the same thing. It's just size of int times 10, but it zeros it all. So then we'll have basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll have that. And this is going to point right here, B, to the start of that block, this one. Just like A currently points to the first one in that block too. And we're done with it, we pair apparently. Free A. If we freed B as well, we'd be freeing the same thing, because B points to the same place as A. This would cause a segmentation fault. Crash. Technically it's undefined behavior, right? But I've only ever seen it crash. Don't want to do that. Anyway, the reason I bring that up is if we copy S, say we have another string, we'll call it S2, and we say S2 equals S1, what's going to happen is now it's going to copy all of the members right here, these two. So I'm going to copy the string, which points to some address to free and to use, and the length of the string. That sounds fine, but as soon as we get out of scope, these both end at the same scope. So it's going to delete S right here, and it's going to delete S2 right here as well. And it's going to call the destructor. The destructor says, hey, is this non-null? If it is, then free it. Well, we know it's non-null because we set the string to this, and we set the string, we stir dupe, which means we allocate a new block of memory, return that block of memory, and it fills it full of whatever we passed for the string. So it makes a new block of memory, copies the string into it, and returns it, and that's stored here. And since we copied that, they're both pointing to the same position in memory that needs to be freed. And that's non-null position, so they're both going to say, hey, it's a real block of memory, let's free it. So let's watch what happens now. I'm going to, let me do this. Finished, right? And I'm going to say f-flush, send it out. I'm also going to do that. So g++ test p test. Okay, test SCP 49. Yeah, I called it S1. It's actually just S. Okay. So that should crash. So we called string. We called string again. You can see finished, and then both destructors should be getting called, but they aren't anymore. So it crashed on the second destructor. So here's what I'm going to do. I'm going to show you where the crash happens. That is right here. You notice we never saw this till the string being called. So I'm going to do this, f-flush, standard output, and make sure it actually writes everything to the console before it crashes when we call this a second time. So flush. Okay. Boom. So you can see on the second one is where it crashes. You can tell it crashes there because we never make it to finished. Now, here's how we fix that. Like I said, what's happening is we're just copying these values, which means they both have the same address, and they're both trying to free it. So it's freeing twice. So what we need to do is when we're copying the class object, we also need to make copies of things that are pointing to a block of memory. We're going to make a separate instance of this string right here in a new block of memory that's going to be stored in the second class, which holds the copy. So by default, what happens is there is what's called a copy constructor. This gets made for you automatically, and it'll work in cases where you don't have anything that, how do I say this, can't be shared, like any kind of resources that can't be shared, like a file handle. If it's closed in one, then the other one couldn't use it if they share the handle. If it's like a buffer memory, that can't be shared, because once it's freed in one, you can't free it in the other, or access it in the other. If it's like, I don't know, OpenGL API you're using or something, or like DirectX or any kind of like graphics API, you might have a handle to a texture or to something like that, right? And if it gets deleted in one class, it won't exist for the other class. So you have to be really careful when you're copying anything with like resource management. If it's just, you know, primitive types like integers, you're fine. Or even if it's something that's like char C-array string like this, and say it has 255 bytes, right? In this case, it's just going to copy the whole array. You're totally fine. It's only the fact that it's dynamically allocated and pointing to a block of memory, which gets freed later, that's causing a problem. Anyway, so the copy constructor takes a constant class type reference. So this is the class type right here. It's constant, and we're referencing it. I'm going to call it old, and I'm actually going to implement my own version of this. I'm going to show you how they implement it, they being the people who wrote the compiler, who automatically generate the code whenever you're making a C++ class like this. I'm going to show you what it looks like. So we have string, : so it comes from the string class, and it's called string, so it is a constructor of the string class, and this constructor takes a constant string reference that I'm going to call old. Now, in this constructor, what they do is they basically just say m lpsc string equals old.m lpsc string. So we're copying the address, right? It's a shallow copy. It's not actually copying the resource by creating a new instance of it. It's just copying the handle or the address. So in this case, we're going to say mst length equals old.mst length. And this one's fine. There's no resource here. It's just a value. So the problem really is this. We're just copying the address. That's what the default copy constructor is doing, just copying everything bitwise. So instead of this, we're going to be a bit more intelligent. We're going to say lpsc string equals strdup. So we're going to duplicate the string. It's going to allocate a new block of memory. It's going to stick the string into it, I copy it over, and then it's going to return that block into this variable. Okay, so old.mlpsc string. So it's going to duplicate the string at this address, copy it to a new block of memory, and return it into here, and store that. So now what's going to happen when this copy instructor gets called, is going to have its own block of memory that it can free separately and safely. So, the other thing I want to do here is I want to say the same thing I've been saying over here, like this is what's being called, right? Okay. Okay, you can see finished here. And the structures get called after finished. That's because they don't go out of scope until the function actually ends and hits that curly brace. So that's pretty neat. It calls the constructor, we set the string, we call the constructor again, it gets finished, calls both these structures, and we're fine. I want to make this a little bit more obvious. I believe that GCC has something called pretty function. Let me see. GCC pretty function. Yeah. So, let's see here. Function. We're going to replace that with pretty function. Yep. Okay. There we go. Now you can see the whole thing. This is the default constructor. Default constructor again, it looks like, which is kind of weird. It should be calling a copy constructor. Let me just write that out. That's making me paranoid. Where is my constructor? Right here's the copy constructor. Okay. I'm going to say copy right here. Why is it not calling the copy constructor? Think about that for a second. Oh, right. This is... I was going to show this next anyway. I'll do that in a second. So now it's going to call the copy constructor. So if you assign it while you're creating it, so I'm saying I'm creating something and it equals this, then it calls the copy constructor. The other way you could do it is if you said it equals like string, you know, s or whatever. You might want to do something like that, but I want to get into that later. So anyway, this should call the copy constructor now. There you go. You can see right here it's calling the copy constructor. Alright, so next thing I'm going to show actually is this. So if you've already created the object, string s2. So when I create this, it does the default constructor. The default constructor was right here. All it does is say it called it, and it flushes standard output, so you can see that it said that. Yeah. So if you assign it afterwards, then it has to call what's called the copy constructor. I mean the copy assignment operator overload. So the copy assignment, you can imagine assignment is just like, you know, A equals B. You're assigning A to B. You're telling the compiler to make it so that A has the same value as B. You could do that with class objects / structures because they're basically the same thing. So I'm going to define that over here. So string const and string. You know what? There it is. Right. Copy that. So what you can do is you can say operator equals. So this class, whenever you say it equals something, that's what that means, is going to return a string reference, which is reference to this string. Okay. And really the name of the function is kind of like saying the name of the function of equals. And you're passing it a constant class to copy from. It's constant because we're not actually manipulating it. Anyway, I'm going to copy this. I'm going to stick it right below the copy constructor. Okay. I'm going to return asterisk this. I'm dereferencing this. Remember, this relates to the name of the class, and it's a pointer, so it's a string pointer, right? That's what it is, one of these. So if I take a string pointer and I dereference it by saying string, right, then what I get is a string object. And that's what I want. I want to return a string, but I'm referencing the string. So anyway, that's what I'm doing. I'm giving them a string, which is going to be referenced like that. Okay. So I can basically just steal the code from here. Okay. So it's bad. Others double free. Okay. Copy equals or copy assignment, I'll say. Okay, so 36, I messed up something. Let's fix that. So, must be non-static member function. Right, I didn't actually say it comes from the string class. So you gotta remember, between the return type, right here, which is its string reference, and the name of the function, which is operator equals, you gotta put that type, class name, colon, colon. Okay. There. So in this case, he is copying with the assignment operator. Okay, and the reason, by the way, that this returns a reference to itself is because you can actually do this. You can say, like, string s3. You can say that s3 equals s2 equals s, right? That'll also work, see? You can chain these operations because whatever it equals returns, or whatever, what do I say, the result of the assignment is what's returned to the left of it, and you can keep doing that over and over again and chaining it. I mean, that's true in general. If you have something like int a equals 1, int b, let's say, and int c, you could say c equals b equals a, right? So b is going to equal 1, and c is going to equal whatever the last thing was, which is b, which is 1. So that'll work. So that's why you return reference. What else? You know, I killed one more than I needed, I think. That's s2 equals s. So I'm going to break this up a little bit. I'm going to say copy assignment. It's right here, copy assignment. Test. This is going to be copy constructor test. Okay. The next thing I want to show is the move constructor test. Okay. In this case, we're going to say string s2 equals move s. And for that, I'm going to need to include our first C++ header, utility. Okay. Trying to think how I want to do this. So for a move constructor, what we're going to need to do is we're going to need to give it a class type, double reference like this. Okay. And it's not const, because it's going to move from it. It's going to take all of the values here, and it's going to be able to manipulate them, and also move them into the next class instead of copying them. Which, I mean, you could look at copying them as actually just start moving them as being copying, as long as you destroy where it came from as well. So this is an interesting way of handling the problem as well, because you don't need to actually make a copy of the block of memory and manage it in two places. You can just literally make it so that the first one no longer owns that block of memory. So that's what I'm going to do here. I'm going to say string again, takes a string, full reference here thing, old. I believe you're supposed to make these no except technically. You're not allowed to throw exceptions in a move constructor. So you're going to say that m LPSC string equals old dot m LPSC string. So copy the address. Right? Normally that's bad. We didn't want to do that earlier because it was going to be double freed right here in the destructor, but we're going to fix that because we have mutable access to the one we're moving from. We're going to use that to fix it. So length equals old dot mst length. Now what we're going to do is we're going to say the old and LPSC string equals null pointer. So we're invalidating the object we're moving from. And we're also going to say old and st length equals 0. So we're basically putting this back into the default state that it starts with, like this. Okay? So now, what's going to happen is I'm going to say, okay, create this, set the string, which is going to allocate memory for it by using stir dupe, and it's going to store it in here. I didn't actually set the length in there. I probably should do that. Let's see, where am I actually doing set string? Where is it? Right here. Get string and set string. Okay, we're going to say st length equals strlen, which is string length, of LPSC string. So I'm actually storing the length too. Okay. Something else I want to do too is I want to just make this bool, and if, you know, we fail to allocate memory for the string, return false, otherwise it's return true. And, you know, up here where I'm freeing this, I might also want to say mst length is 0. That way, it's in an obviously invalid state. Okay, that means I have to change the definition as well of set string to take a bool. Alright. Anyway, so at this point, we've set the string, so s dot m, if you can imagine, LPSC string, it now points to a block of memory that holds testing. Yeah, testing. We can't actually access this like that because it's a private member, but we can get to it with, you know, s.get string. Alright, as we do right here. So, anyway, then what we're going to do is we're going to move from it. So this is saying create a new string and take the contents of this one, store it in this one, and then make these contents whatever they were by default when I first constructed it. So what I'm going to do is I'm going to wait to actually print that out until after I do this. I want you to see that the contents are going to be invalid now. Oops. So what did I do wrong here? We have no except is different. Right, I never actually defined it as no except. I defined it over here. No except. Okay. There you go. So you can see here's a string null because we moved from it. We took the class members and we invalidated them when we made the move. So we're calling the string default constructor, and we don't see the other constructor being called, which is the move constructor. So probably, yeah, I didn't actually print anything inside of it, so that shows you right there it got called, but oops, I don't want to say copy, I want to say move. This is a move constructor. Okay. There we go. Now you can see the move constructor was called. Okay. And now just to show you that it actually has that data in the other class, I'm going to say, yeah, I'll just copy this and print it twice. 2. So print from the original object, so the string object, print from the object into which we've moved the original string object's contents. Okay, now you can see testing. It came from the second string. Now there's one more type you need to sometimes define, and this is the move assignment operator. It's going to return a string reference, operator equals, and this time instead of being const string, it's just going to be string double and here, old. Okay. Now for this one, I'm going to stick it below the move constructor. And it's basically going to be the same thing, right? So I can just steal the code here. Boom. Not move, is it going to be... So it's move equals, move assignment, let's say. Now for this one, it would already have to be created. So string s2, links to s2 equals standard move s. So move assignment test, right? So I didn't like that. CY 57, non-static function. Right, I didn't. Same thing as last time. I forgot to use string ::, the class name : That's where this method comes from. Can't speak English anymore. Okay, so no return. Right, I forgot to return. Remember, it returns the class type as a reference, and this is the class type. It's a string pointer, right? So I'm going to dereference that to get just a string. And it's going to add this reference right here to it automatically, because that's the type I'm saying I'm returning. So return this. Alright. Okay, and you can say the, right here, string operator equals string move. The move assignment operator was called. You can see it works just the same as the move constructor. Okay. So we have the default constructor, we have the copy constructor, we have the copy assignment constructor or operator, we have the move constructor, we have the move assignment operator overload, and then we have the destructor. So 1, 2, 3, 4, 5, 6. I believe people would call this the rule of 6 or something like that. I don't know. But the only other thing we can actually do that you should know about is you can make other constructors besides the default copy and move. So if you want to initialize these to some value, you can make a constructor that does that. So usually that's one of the first things I do. Since it's holding a string and the length of the string, I would typically make a function that does something like char reference obviously string. This is a string I want to assign to this, right? And then comma size t length. Or maybe I don't even do that. Maybe I just pass the string and I let the length be calculated automatically inside this function, right? So I'll do that. I'm going to make this function exist right below the default constructor. I'll do it there. So string : that's where it's coming from. String class. And it's called string. There's the arguments it takes. So lpsc string equals stir dupe lpsc string, and we're going to say mst length equals strlen of lpsc string. So the length of the string. Now, because I'm doing this, I can also show you something else that you should probably know. If not mlpsc string. So if we did not allocate a block of memory, something went wrong, we can't just return false here, because the constructors have no return type. What we'd have to do is either have some member, like be constructed properly equals true or something like that. Maybe it starts out false, or let's say constructed probably equals false, like there's a problem. And you can just test that afterwards. Or what you can do is you can actually throw something. So throw standard exception error failed to allocate a new copy of the past string. Something like that, right? And then what you'd have to do when you create this is you'd have to put it in try and catch block. So essentially, let's see, how do I want to do this? I'm going to take all this out of here. I'm actually going to say this. Void, or actually, I'll say bool. I'll go int. Test is usually what I'll call it. Void. Takes no arguments. It's not very argumentative. Okay, I'm going to say string s. Let me think what I want to do here. Right. I made the new constructor, which I'll say testing123 this time. fdef, about string. The string is going to be string.getString. Okay. When it goes out of scope, it's going to freeze automatically. Cool. So this is going to call the new constructor that I made. So, where is that? It's right here. Let's steal that real quick. So I called this one. It's going to show this, right? Well, it's not going to do anything until I get it to compile. 37. Right, it doesn't know what that is. So that whole standard, runtime error or whatever, or standard exception. I don't know about standard exception, but definitely standard runtime error right here. This one comes from std.except, standard except. And it's still not happy about something. 38, no function called a standard exception. Plus 38, test FTP. Right, I should have done runtime error. Okay. What else is not happy about? 136, no return statement. Right, I should have returned 0. Nothing went wrong. Okay, now we have 141. I just don't like that. Forbids converting. Oh, right. So when you define a string like this, test, the type of this string is going to be a const char. Right. The reason that's constant is if you try to mess with this block of memory, when you define it as being like pointed to, it is going to be immutable and it's going to crash your program, or at least have undefined behavior. Now, if you define it like this, char law equals, test, in this case it's mutable, you can do that. But if you're defining it as a pointer, it has to be const. So anyway, I'm passing it a constant character pointer to some block of memory. And in my copy constructor, I'm expecting just a mutable, here it is, yeah, a mutable character pointer. That should be pretty const. So, easy enough. +4, so what's it complaining about now? No declaration. Right, so declaration does not match what I just changed. This also needs to be const. Okay. So that's not going to work. I need to run this with PowerShell this time, and it'll work just fine. So I expected the environment to be bad at some point and was prepared for it. Anyway, you can see I called the new constructor that I made. I printed out the string that I stored, and then the constructor got called. So that's something else you can do there. But I'm not quite done yet. So remember, this could throw an exception if it couldn't actually allocate a buffer big enough for whatever reason. So really, you should stick this into a try and catch block. And catch, you know, standard exception. Okay. Exception, right? Pick up the string, e dot what? That's what the exception was. Okay, that's what you want to do. I can't do it here. Keep forgetting about that. Right? There you go. So that's how you're supposed to do it. You're catching the exception. Now the problem with this is the scope here starts here and ends here. So now you have the entire program kind of stuck in this, right? And maybe there's something else you want to create, like some other object. SOO, right? And maybe when you make this, it could cause an exception too. And you might end up with this like nested junk like this, right? What'll really happen is if this fails and I don't catch it here, it's kind of okay because the exception from this will also end up here because it's also in that catch block. I really don't like that though, personally. I like being able to not have everything pushed forward really far. It annoys me. So one thing I might do is I might say string pointer to s, right? Small pointer. And when I actually want to make it, I'd say something like s equals new string, and I pass it the type of constructor I want, right? And if it's a default constructor, I could just say new string like this, or new string like that. In this case, I want to use this. But if you use new, now you have to delete it. So before I showed things like if you have, let's say char p equals char asterisk, gotta cast it, malloc 1. It's pointed to one character, right? When you're done with it, you have to say free p. Well, with new, you don't use free. What you use is you use delete. So delete s. And if I make a new array of something, like say I do a new, I'll use char again. So char, let's say p equals new char 10. So this equals a new block of 10 characters. When I delete it, I have to say delete with brackets, like delete array, p. So it's important that if you make new with brackets, you have to delete with brackets. If you make new without brackets, you have to just use plain delete. Otherwise, you're leaking memory. Okay, so I could do this, and this should be valid. In fact, I'm going to say if s, then do that. It's not happy, so test dp, before. Oop, I put string instead of string. That would do it, wouldn't it? Okay, now it's 135 this time. Test .cp. What else isn't it like? Oh, right, because it's a pointer now, right? So the type is string pointer. When I actually want to get the string from it, I have to do an arrow operator now. So test test. Can't do it here, right? So I gotta come out here, run it here, and it still works, see? But the advantage of this method is that I can take this, right, and do it out here, right? I don't have to nest anything. If this fails, I can print the exception. I can be like, okay, give up, return 1 in error code, and I'm just done. Otherwise, continue along. I know I need to free it at some point. So let's show that. Dang it. Fine. There we go. Okay. So next thing I want to show, before I stop this, because this is getting pretty long, I think, is what's called smart pointers in C++. What you need is, what is it, memory, remember, memory. And this includes things like standard shared PTR of some type and standard unique pointer of some type. So essentially, what you can do here is you can say what I have right here is a string pointer, right? But I can wrap that in an object called a standard unique pointer. So unique pointer to a string. And by default, it's already null. It does that for you when you create the object. It's built into that constructor. And the destructor, if you can imagine there's something like standard namespace, right? I'll write this out real quick. So namespace standard, right? So you have something like that. And here you have like class, unique, pointer. And it's actually a template class. It's like template, you know, I'll say type name. T and unique pointer T, and it's not even that. Just really it's gonna be like public. I'm trying to keep it as short as I can. Unique pointer is going to be public, or just, dang it, private rather. You have some member, and this type is T, whatever this template type is. Some type reference, right? I don't even know what I call it, just like TX, whatever. Say it starts out at null pointer. So you have your constructor, and you have your destructor, unique pointer. And this unique pointer destructor, you can imagine inside this namespace, there's something like it'd be unique pointer T. In fact, you know what, it'd be, that's where it comes from. I haven't done this in a little while, and it's called unique pointer, it's a destructor. So, in this destructor, it's actually going to free whatever this memory is for you. And I think there might be a different template for like this versus this, so it knows to call delete or delete like that. Either way, this is going to get called rather whenever this object is deleted, and this object right here is created within the scope. If I had created a unique pointer, so pointer to a unique pointer somewhere, then this wouldn't get freed when the scope ends. But this is an object that basically holds a pointer for me, and this object itself goes out of scope, and when it hits its destructor, it's going to, you know, delete what's inside of it, which is the string class. So that's kind of the idea of what's happening there. You just wrap things into an object so that you don't have to worry about calling delete or delete with brackets like I was showing earlier. So I'm going to say uptr for unique pointer s for string, or unique pointer string, or whatever you want to say. I'll say unique pointer to s. Okay, so what you could do is you could say standard make unique, right? So you can make a unique pointer like that. And I think you have to specify the type too, like string. Down here, I shouldn't need to do this anymore. But over here, what I'm going to need to do, where is it? Right here. So uptr s, you do .get, and that gets the actual string inside of it. So right now what I have is like a standard unique pointer of some type, and the type is string, so it's holding a string pointer for me internally. And then when I do standard unique pointer type get, that returns the underlying type right here. It's going to return the string pointer. And because it's a string pointer, I have to use the error operator rather. So that's what's happening there. Let's see what I got wrong, because I'm sure I messed something up there. Actually, it's not going to compile on this one anyway, so I gotta get over here. Oh yeah, we got some errors. 145, what isn't it like? S is not in the scopes, 145 is the problem. Okay, was it underscore? Yeah, 145. Right, so it's ptrs. I need to not do that. Okay, okay, what else isn't it like? File included from here. No meshing function call to string. Okay, conversion from. I'm guessing it doesn't like the standard make unique. I haven't done it this way in a while. Hold on a second. There was a old way to do it that I wanted to show first. I think I should do the new way just now. Yeah, this is the new way. The other one I wanted... What was it? Was it just standard unique? Let's see if I can find that real quick. Unique pointer node. Yeah, they're all showing the new way when I'm looking at the documentation right now. There is a way where you can take an existing pointer, though, and wrap it. Okay, new pointer, wrap existing pointer. Yeah. Yeah, I mean, I guess what I could do, maybe this is what I'm thinking, but probably not, is I could just say this equals standard unique pointer of this type and wrap it around that, but I don't think that was the way I needed to do it before in the old version of C++. Okay, well, it does work. So that is a way you can do it. You're saying it equals basically a copy constructor of this object that I'm creating right here. I'm wrapping it in a unique pointer. But the other way to do it is to say uPointer s. This is the way you should do it. Standard make unique. Okay, and the type is string. And you're just going to pass whatever constructor you'd like. So testing 1, 2, 3. Right? So what happens here with this make unique is whatever you pass into here, it's going to pass that into the constructor of the type that you mentioned. So if I add another thing here, like 1, 2, 3, or 1, 3, it's got like a string and 2 integers, it's going to look for a string constructor that takes a string and 2 integers, and it's going to pass all of these values to that string constructor, get a new object from that, and then whatever that new object is going to wrap it in this class, and it's going to return this unique pointer class of this type and store it in this variable. So that's a lot of stuff going on, but it's a little bit easier to read and work with than wrapping this in a new constructor call right here like this. I did it again. At some point, I promise I'm going to use a real IDE. There we go. And that works the same, see? Anyway, the cool part about that is if you wrap something in a unique pointer, you don't have to worry about calling delete on it. It's just going to delete automatically once the unique pointer is out of scope. Now, there's another one called standard shared pointer. You could do that, shared pointer to string. So SPTR would say shared pointer string. And it works exactly the same way, except a shared pointer, every time you copy it, so if I do another shared pointer, shared pr string, SPTR s2, I could say this equals SPTR s. Now, both of these objects would have to go out of scope and be deleted before it would free the string that they contain, because they're sharing that string. Both of these have to die before the string will be deleted. With the unique pointer, you're saying there'll only ever be this one pointer pointing to it. And in fact, if you want to make a copy of it, or even put it into another variable somehow, like say you're returning it from a function, you would actually have to say like standard unique pointer string, call this uptr s2, equals standard move. So you're moving the pointer around from uptr s. So this is valid, right? So valid, but standard unique pointer to string uptr2 equals uptr s. Invalid, right? I'll show it doesn't work. It'll actually complain about that. Well, it's going to complain anyway because okay, 144 deleted function. Yeah, so use a deleted function. It won't let you do it. So I'll show this one does work when I compile it. See, that's fine. Although it's not going to actually be able to do much with it, right? Trying to think here. I'm kind of surprised this is still getting me something because I moved from it. I wouldn't expect this to be valid. It shouldn't really be in a valid state if I've moved from it. I did recompile it, right? Yeah, I did. That's interesting. It's giving me test 1, 2, 3. Maybe it doesn't actually put it into an unspecified state when you move from it. That's kind of strange. I'm guessing I'm invoking undefined behavior there, but I would expect move to do something like uPointer s dot reset or something. I think there's a reset. Yeah, there's a reset. So why is it actually letting me do this then? This shouldn't work. uPointer s get should give me something invalid. Let me check that real quick. I'm going to say string pointer to, let's say lp string equals uPointer s dot get. And I'm going to say if not LP string. Let's just return 0. The string we returned was invalid, right? That probably should come up. I'm guessing I'm just using a invalid object here. Was not LP string 156. Yeah, I typed LPSC string. It's a long pointer to a string object. Okay. That's very interesting. I don't expect that to be correct. Moving from unique pointer to S. Oh, it's because I never actually made it yet. Derp. Okay. Fine. So I'll make it first, and then I'll move it. Wow, that was a bit silly. There we go. The string return is invalid. That makes more sense. I'm like, man, I must be doing something weird. Like, obviously I shouldn't be using it like this anyway. I should be checking to see if it's valid like this first. And then if it's valid, I should be saying, you know, LP string like that. That way it's safe. So compile it. Yeah. Complaints is invalid. Now, what I'm going to do here is not move it away. There we go. So it'll actually work. I'm going to leave the code like that, I think. And this will be what I put into the GitHub project. Here's on, what is today's date? It is 2024-08-02 by the constructed coder. Purpose to show the basics of C++ classes. We got copying, we got instantiation, we got moving, move, assignment, we have copy, assignment, on default constructors, unique pointers, shared pointers, although only brief overview. What else? Constructors. I guess you could say scope, question mark, I don't know. Right, I also covered new, delete, and new brackets, delete, brackets. I think that's about it. Feel free to leave any comments, like, subscribe. Any feedback would be very much appreciated because this is some pretty complex stuff. I tried to speed run through this as much as I could because I think this would be a good video to be an overview for people to look at these concepts and what to keep in mind when they have classes that can't be copied with a shallow copy. Anyway, thanks for watching. I appreciate it like always. You guys have a nice day.